Greetings to all the viewers out there and welcome to this further math tutorial to prepare you for the GCE examinations and for other exams. In this particular lesson, our focus is going to be on matrices, further matrices, and we will consider the aspects of introduction. Please don't forget to click on the subscription button as we progress with the lesson and follow the lesson to the end. A matrix is defined as a rectangular array of numbers with each number called an element or an entry. Matrices are denoted by capital letters, and elements on a horizontal line constitute a row, while elements on a vertical line constitute a column. Let's consider, for example, the matrix denoted M below. The entries of this matrix are A11, where the first one represents row 1, and the second one stands for column 1. So this is an entry of row 1, column 1. This next entry is an entry of row 1, column 2, row 1, column 3, and up to row 1, column n. So there are n columns in this matrix. Now let's take the first entry of row 2, column 1. So we have row 2, column 1, row 2, column 2, row 2, column 3, up to row 2, column n. And the last row is row m. And the first entry of the last row is AM1, AM2, AM3, where AM3 is an entry of row M, column 3. And the last entry is AMN, where this is an entry of the mth row and nth column. So this matrix has an order or a size of m by n, where m represents the number of rows and n the number of columns. So the elements, for example, A23 is an element of the second row and the third column. The second row and the third column. Here we have row 1, row 2, row 3, and up to row M, the mth row. And we have the columns, column 1, column 2, column 3, up to the nth column. So a matrix has m rows and n columns, and thus is having an order of m by n. This is also called the size of a matrix. For a matrix where the number of rows equals the number of columns, or m equals n, the entries along the leading diagonal, or A11, A22, A33, up to AMM or ANN, constitute the leading diagonal, and the matrix is known as a square matrix. So for a matrix to be a square matrix, the number of rows must be equal to the number of columns. Examples of matrices here that we have, which are square matrices, are you have the identity matrix of order or size 2, and the identity matrix of order 3 or of size 3, as they are denoted. So any square matrix in which the leading diagonal entries are each 1 and there are zeros elsewhere is said to be a unit or an identity matrix. So this is an example of an identity matrix of size 2 or of order 2, and an identity matrix of size or order 3. Recall, addition, subtraction, multiplication, and other operations with matrices, and the use of the inverse to solve a system of equations. So you have to revise all of that so that we can use all of those concepts here in further matrices in additional mathematics. Now let's look at some operations with 2 by 2 matrices. The determinant of a 2 by 2 matrix M with entries A, B, C, D is denoted by M or det M, where det M is the product of the leading diagonal entries minus the product of the off or reverse diagonal entries. The adjugate of a 2 by 2 matrix is obtained by swapping the entries along the leading diagonal and changing the signs in front of the off diagonal entries. So we swap A and D, and we change the signs in front of C and B. The inverse of a 2 by 2 matrix is the quotient of its adjugate and its determinant, or it is 1 over the determinant times the adjugate of that matrix. The transpose of a 2 by 2 matrix is obtained by changing rows for columns or by swapping rows for columns. So this first row AB now becomes the first column AB. The second row CD becomes the second column here, CD. And all of these properties are very important as we look at the properties of 3 by 3 matrices and higher matrices in further matrices. Let's note the following as well. The determinant of a matrix M is equal to the determinant of its transpose. The transpose of the product AB is the same as the product of the transposes of the matrix B and A. B comes before A. The inverse of the matrix AB is the same as the product of the inverse of B and the inverse of A. So these properties are very, very important as we will be moving into the lesson, and it's very important to revise all of them as we work on this complete tutorial. Our next lesson will be on the determinant of a 3 by 3 matrix and higher matrices. Equally, in this lesson, we are going to look at properties of 3 by 3 matrices, Saru's method for determinants, and numerous examples. Please stay tuned and share these videos with your friends, and don't forget to subscribe as we move on to the next lesson on Math 24 Super Channel, also working together in collaboration with Math 24, broadcasting here in the United States of America. I've been your host, Miles. Goodbye.